Good morning to all of you. This is Somshekhar, Assistant Professor of Mathematics, Sarami Government Science College, Mamunkatte, Bhadravati. Welcome to my first session of the unit Differential Equations of First Order, but not of the first degree. That means higher degree. Students already know about the solutions of first order and first degree differential equations. In this session, we are going to study how to solve the differential equations of first order and higher degree. The requirement to this session is students should know how to solve the first order and first degree differential equations. Let me come to the main content. Before going to seeing the solutions of this type of equations, let me have the general form. The standard form of differential equations of first order and nth degree is like this: dy by dx power n plus a1 into dy by dx power n minus 1 plus etc. plus an into y is equal to 0, where a1, a2, etc. an, these are the functions of x and y. These are the terms in x and y. It is important to keep this type of equation to simple form. For this, take p is equal to dy by dx. Then this equation reduces to like this. Definitely, this is the simplest form of this equation. Please remember, throughout this unit, differential equations of first order and higher degree, p is dy by dx. Please remember this representation. Here p is dy by dx. There exist 4 types to solve this type of equations: solve for p type, solve for x type, solve for y type, and Clairaut's form. Let me have the first type, solve for p. If the LHS of 1 can be written as the product of linear factors of p, then it belongs to solve for p type. Let me have some problems. Solve p square minus 5p plus 6 is equal to 0. Consider this equation. Please observe, this equation contains only p term. Therefore, here there is no doubt, and definitely, and this is of solve for p type. Factorize this, and it's a quadratic equation. Factorize this. If you multiply, we should get plus 6. If we add or subtract, we should get 5. Consider those two terms. Those two terms are 3 and 2. After multiplication, definitely we have 6, and after addition, definitely we have 5. And give the sign to the biggest number as in the middle term. Here minus is there, so the biggest number takes minus sign, minus 3, but we are adding to get 5. That means the another term also takes minus term. And therefore the factors are p minus 3 into p minus 2 equal to 0. P minus 3 is equal to 0 or p minus 2 is equal to 0. That means p is equal to 3 or p is equal to 2. But p is dy by dx. dy by dx is equal to 3. And this is the first order, first degree differential equation. Solve this equation. We can solve this equation simply by separating the variables. Separate the variables. Dy is equal to 3 into dx. After the separation, we already know we have to integrate so that we get a solution. On integration, the integration of 1 with respect to y is equal to the integration of 3 with respect to x is 3 into x 3x plus some constant c. It is also important that keep this equation in this format. That means the RHS always should be 0 so that it is easy to write the solution of the given equation. Bring all the terms whatever we have in the RHS to LHS so that the RHS becomes 0. Y minus 3x minus c is equal to 0. And this is the solution of this equation. P is equal to 3. Now P is equal to solve this equation as in the earlier. dy by P means dy by dx is equal to 2. And this is the first order first degree differential equation. Separate the variables. dy is equal to 2 dx. On integration, y is equal to 2x plus c. Bring these two to the LHS. Y minus 2x minus c is equal to 0. The solution of the given equation is of like this. Take the product of the LHS of these two solutions, y minus 3x minus c into y minus 2x minus c, equate these to 0, and this gives you the solution of the given equation. And this problem is exactly similar to one, and please follow this problem. Now I am taking the different problem. Solve this. And this is the given equation. xyp square, isolate this term, multiply by p, minus x square p, minus y square p, plus xy is equal to 0. And take xp common from these two. We get yp minus x, and take negative y common from these two. We get negative becomes positive, yp minus positive becomes negative minus x. Here y is the common, that means the remaining is x minus x is equal to 0. Once again take yp minus x common from these two. The remaining is xp minus y is equal to 0. Now here I am writing the LHS of this equation as the product of linear factors of p. And this is the linear factor of p. This is the linear factor of p. So here I am writing the LHS of the given equation as the product of linear factors of p. That is why it is of a solve for p type. Now solve for p. Yp minus x is equal to 0 or xp minus y is equal to 0. Solve these two equations. Y into p is dy by dx is equal to 0. First order first degree differential equation. We can separate this very easily. Y into dy is equal to x into dx. After the separation, integrate. On integration, y the integration of y square by 2 equal to the integration of x is x square by 2 plus ಎಲ್ಲ ಕಡೆ ಡಿನಾಮಿನೇಟರ್ 2 ಇದೆ, ಫ್ರಾಕ್ಷನ್ 2 ಇದೆ, ಎಲ್ಲ ಕಡೆ 2 ಇದ್ದಾಗ ನಾವು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಫ್ ಇಂಟಿಗ್ರೇಷನ್ನ c by 2 ತಗೋಬೇಕು. We can avoid this fraction by taking the constant of integration as c by 2. Multiply 2 throughout, y square is equal to 2 gets cancelled, x square, bring this to left hand side, minus x square, plus 2 gets cancelled, bring this to left hand side, minus c is equal to 0. Denominator ಎಲ್ಲ ಕಡೆ 2 ಇದ್ದಾಗ take the constant of integration as c by 2 so that we can avoid the fraction. xp minus y is equal to 0. X into p is dy by dx is equal to y. After the subtraction, dy by y is equal to dx by x. On integration, 1 by y in the integration of log y is equal to 1 by x in the integration of log x plus, here log is there everywhere, so take the constant of integration as log c1. Log y is equal to log of x c1. Log m plus log n is log of m into n. Log of x c1. In both sides, log gets cancelled. Y is equal to x c1. That means y minus x c1 is equal to 0. Therefore, the solution of the given equation is the product of LHS of these two solutions. Equate these to 0. There are some exercise problems. Please go through this and follow these references. Thank you for watching and see you in the next session.